Hello and welcome to EGN 3613. In this session we will continue with non-equal payments, or what's called unconventional payments. In this example, in this cash flow diagram, we can see that we have non-equal payments over the years. We can identify four different groups. The first group, which contains only one payment, that's $50. Then a group of three that will contain the three payments of $100. And then a third group, which is four payments of $150. The fourth group is one payment of $200. So those are the four groups that we can identify. Now the way to do it is to bring all these payments back to zero. And to do that, for the 50 will be directly using the future value and bringing that future value, the 50, into the principal or the present worth or present value. Using the formula B given F with 15% interest and 1 year, we will get $43.48. So that will be for the first group, or the first payment that was brought back to year zero, or to time zero. For the second group, now remember that we are going to bring the second group, the whole group, we are going to calculate that and bring it back to year one. And from year one, we have to bring it back to time zero. That's why, I will calculate using the formula, which is the annuity, finding the present value, and the present value will be here, and that will be P for this group, for group number 2. So I'll bring the P value here, and then that P value will be brought back to time zero, like that, with consideration that it will be 1 year. Now from this point all the way back to time zero, it will be 1 year, and the interest rate is 15%. And you can recalculate the value. For group number 3, we have again the group with $150. That will be brought, all this group here will be brought back to year 4, and then we can bring it from year 4 all the way back to year 0. And the same for the last group. Now, if you can see it confusing like that, let's do it separately. So again, let's do it differently. And this is time 0 for me. And this is the p-value that I would like to calculate. So for the first one, this is the $50 that will be brought back 1 year to 0. I will consider this as future value. So this is F value. I need to bring this future value to the present value. And to do that, we can write P is equal to the future value F multiplied by the P given F with 15% rate and 1 year. And this is year 1. That's why I have here number of periods is equal to 1, which will equal to $50 multiplied by the factor P given F, which is equal in this case to 0.8696, and if you multiply these together you should get $43.48, and that will be for the first group. So this is P for the first group number 1. Okay, now what I'm going to do, I'm going to clear the page and find P for the second group. Now remember that the second group starts from 2, so I have 2, 3, and 4. This is 2, this is 3, this is 4. This is year 1, and at 2 we have a payment of $100, and $100. So those are the 3 payments of $100. This is the second group. The second group, I will consider this as annuity A. Since this is annuity A, then I can use the formula that says P will equal to P A multiplied by P given A with 15%. Now let's look at the number of periods. I have period number 1, this is period number 2, and this is period number 3. So I have 3 periods here, and I should return this value, I should return these values, the annuity, to year number 1. So until now we didn't go back to 0. We did not go back to 0. We went to year number 1 using this formula. Now to go back to year 0, we have to multiply whatever gonna yield from this one, and the yield will be multiplied by the year, this year here. Let me do it in a separate one. Let's assume that this one will be called P prime. P prime. So this is P prime. I will find P prime first. A is equal to 100. Then I will multiply with a factor. The factor is P given A with 15% and 3 years or 3 periods. So that will be equal to 2.2832, and that will be if you multiply that using the calculator, $100 times 2.2832, and that will equal to 228.32. Now we're done with the first calculation. Okay. Again, I want to return P prime now to year 0. So I will consider this as a future value for the present. Future value for the present. So in this case, I will use what is the P value, the new P value that I want, which is for group 2, which will equal the future value F multiplied by P given F with 15% and 1 year. 1 year. This is 1 period only. and that will equal, now remember that F here is the same as the P prime that we got over here. So it will equal to 228.32 multiplied by this factor. And this factor is P given F with 1 year will equal to 0.8696. So we multiply by that and we will get P for the second group, which will equal to 198.54. So that will be the second one. So now I got the first P for the first group, which is the 50. Now the P for the second one, for the second group, and we can go for the third group. Now for the third group, this is year 1, this is year 2, 3, 4, 5, 6, 7, 8, and this is 9. The payments here happened on year 5, 6, 7, and 8. The amount is $150. So it will be $150 for each. Now I will consider this as annuity, and I will return their value to year 4. Remember that I have the number of periods equal to 1, 2, 3, and 4. So those are the number of periods. Since I have 4 periods, 1, 2, 3, 4 periods, then I will use n is equal to 4 in this case. Now let's recalculate. P at this point, which is P double prime, will equal to 150 times P given A with 15% and number of periods 4. Again, from the tables we can find the factor, and the factor for P given A with 15% and 4 is equal to 2.8550. We multiply that by 150 and the value will equal to 150 times 2.8 150 times 2.8550, and that will equal to 4.28 and 25 cents. So this is the value for the P double prime on this line here. Now what we are going to do, we will consider that P double prime here as future value for P of group number 3. So I will bring the future value here back to year or time 0. To do that, then I will take the P for group number 3, which will equal to the future value, or the P double prime, it's the same, multiplied by, look at the number of periods. This is 1, 2, 3, 4. So multiplied by P given F with 15% and number of periods is equal to 4. Calculating the amount will equal to 244.85. And again, you can use the calculation or use the tables with the calculation that we got here to find the value, which is $244.85. And this will be for group number 3. So far we have 3 groups. Now let's again clear the page and go to the last group. The last group is only $200 at year number 9. So I will consider this as future value that should be returned back to time 0 and find P for group number 4. And to do that, we just use the formula P is equal to F, P given F 15% and number of periods is 9. And that will equal to $56.85. $56.85. And this is P number 4. Okay, now what are the values that I got? We have total P will equal to P1 plus P2 plus P3 plus P4. P from group 1 is equal to $43.48. P from group 2 is equal to $198.54. P from the third group is equal to $244.85. And P number 4 is equal to $56.85. Adding these values together should give you $543.72, and that will be the final value for P over here, coming from all 4 groups, from the 50, from the hundreds, from the 150s, and from the 200. So we managed to get all these values back to one value, which is the present value, the current present value. That's $543.72. And that was the example that we have here. So even if you see it like this, it's not complicated. Just break it down into pieces and try to bring it back to year 0 or to time 0, and it will be easy for you to handle it, whether it's a future value or annuity that you need to bring it to a certain point and then bring it back to time 0. It's always easy to think if you break it down into pieces or small parts. Now let's have another example. We have 4 annual deposits of $100 in a savings account, which is earning 10%. So in this case, we have the interest as 10% for 4 deposits. Those are the deposits that I have here, and those are for the first 4 periods. What equal annual amount can be withdrawn over 4 subsequent years? Now remember that you are saving these in a saving account and you are getting interest 10%. So I would like to calculate the annuity that I can withdraw over the next 4 years. How can we solve that? You know, again, if you think about it in 2 separate pieces, or if you break it into 2 separate pieces, that will be easy. The first piece, or the first group, is the 100s here. This is the first group, and this is the second group. And you have to remember that this is deposit, so this one is inflows, and they should be in positive if they are inflows, or it's positive for the bank, negative for your pocket because you are depositing that out of your pocket. So it could be negative for your pocket, and you are getting these back later on, so it's positive for your pocket. So this is negative for you, positive for you, because you are paying these out here and you are getting these back over here. So those are the 2 groups that I have, deposits and withdrawal. Deposit and withdrawal. Now how can I find the amount here, the A amount? How could we find that? How can we find it? Since this is inflows and this is out, the inflow and outflow should be the same or should be equal. So I can bring all this group back to time 0, and I can bring this group back to time 0, and say that P in the principal for in is equal to the principal or the present value for out. So I can make these 2 equal, and then from there I can get the annuity that will be withdrawn in year 5, 6, 7, and 8. And this, we consider this as the first method. Now, could it be done differently? Yes, and I will talk about that method later on. But now let's solve it for this and see how it works. So we have the first group. Let's take time 0, 1, 2, 3, 4, and then the second group starts at 5, 5, 6, 7, and 8. So for 1, 2, 3, and 4, we have deposit of $100 for each month. While for 5, 6, 7, and 8, we have withdrawal of A amount. And I need to find that amount considering that we have 10% interest rate over these years. So I is equal to 10%. And again, we said that we're going to do it in 2 different ways. Let's calculate first the outflows or the deposits. inflows for the bank, outflows for you, outflow for your pocket. So it will be 100 annuity. That means this is P2, which will equal to 100, that's the annuity, P given A with 10% and 4. And again, we use the tables in the back to find the value of the factor. P given A, 10%, 4, multiplied by 100, and we will get $316.99. Now we need to bring A, the group of withdrawals here, back to time 0. So I need to find P1. To do that, first of all, I need to bring all these values to year 4, as we used to. Always we get it back to the year before these payments. And the number of periods is 1, 2, 3, 4. So now let's use the formula. And the formula for that will be A, P given A with 10% and 4 periods. Now I found P here, and I will call it here P prime. So P prime here. Now what we're going to do, we are going to bring P prime, this value, back to time 0, and this will be my future value. So this will equal to the future value. I will take the future value, and that will be 3.1699A. Now remember, the value of A is not known. We don't know the value of A. So we are going to use this until we get the value of A. Now how to find P1? If we go back to P1, P1 is considered as the present value for this future. So the future value, F, which is the same as the P prime here, multiplied by P given F with 10% and how many periods? 1, 2, 3, 4. So I have 4 periods. The factor for this will equal to, so we have, let me write it in a different space here. I will write it here. So P1 will equal to F multiplied by P given F, 10% and 4, which will equal to, for the P or the P prime, it's equal to 3.1699A multiplied by the new factor, and the new factor with P given F with 4 periods is equal to 0.6499. If you multiply these together, you should get 2.1651A. Now notice that until now I didn't get the value of A. So now I have P1. At the same time I have P2. what I'm going to do, I will make these two values equal. So let's get rid of some of the drawing here, and let's do some mathematical calculations. Okay, and we'll say that P1 will equal to P2. That means that 2.1651A will equal to 31699 divided by, if we divide both sides by 2.165 to get rid of it, then this one will go, and A will equal the division of 316.99 by 2.1651, and that will equal to $146.41, and that will be the annuity. So if I paid $100 for the first 4 years, I can withdraw them $146.41 starting from year 5 all the way until year 8. I will pay 100 for 4 years. I will collect them as 146.41 in the year 5, 6, 7, and 8. Let's use another method for the calculation. So method number 2. I have here year 0. I have 1, 2, 3, 4, 5, 6, 7, and 8. And as we said before, we have the $100 for deposited for the first 4 months or 4 years, and I would like to calculate the withdrawal for the next 4 years, how much we can withdraw. As we said, we break it into 2 problems and then we make it equal and find A. In the first method, what we did, we brought them all to year number 0, but that's not a must. Actually, I can bring them to any point. In this case, what I'm going to do, I will bring them to year 4. So I will bring all these values back to year number 4, and I will move these forward to year number 4, and the 2 values at this point should be equal. Again, the inflows and outflows should be equal at any time. That's why we can bring it back to any point. So this year 4, I stopped the deposit, I started withdrawal, then I can bring the withdrawal to this point, and I can move the deposit to that point and make them equal and find the value of A. So if I'm moving these back, and this is P1, or the present at that point, the present value, then P1 at that point is equal to, and I can call it P1 at 4, at year number 4, is equal to A multiplied by P given A 10% and 4. Number of periods is 4, and that will equal to 3.1699A, and we found this value here. Now I need to bring those to the future, so I need to find F. value here, the future value, and the future value should equal to 100 f given a with 10%, and again I have 1, 2, 3, 4, actually 4 periods, because I have also the last one. So we have 4, then we have 4 periods. I have 4 payments, 1, 2, 3, 4. So I will use 4 periods, and that will equal to 464 and 10 cents. So now remember that F will equal to P. So if I made P is equal to F, then I have 3.1699 A is equal to 464 and 10 cents. Dividing both sides by 3.1699, then A will equal to 146 and 41 cents. And again, this is the same value that we got before. So whether you use the first method or the second method, the most important thing is to understand that you can break these kind of questions into 2 pieces or more, and then bring all the payments or the outflows, inflows into a certain point, make them equal, and find the variable that you need, or the missing value. That will be all for this session. If you have any questions, you can email me.